This is lesson 11 of the chemical bonding storyline. We only have one more lesson to go, and we've reached the end of this series. The chemical bonding storyline is titled, Why Do Some Things Get Colder or Hotter When They React? And lesson 11 is reflected in the sixth image up above, and threads nicely into the previous 3 lessons of this second part of the chemical bonding storyline. And it is titled, How do scientists represent the changes in energy in endothermic reactions and in exothermic reactions? It took me about 1.5 cell to teach this lesson. The lessons at my school are about 50 minutes each, and I taught this lesson during the 3rd quarter of the academic school year. Now, to understand how this lesson 11 threads into the sequence, I'm going to briefly pause at lesson 10. Lesson 10 and lesson 9 focused on a simulation that enabled students to model the breaking and the making of chemical bonds. And therefore, I'm focusing again on that very first endothermic reaction that we did during the first lesson of this chemical bonding storyline, where the content of this beaker got so cold that the water underneath it was freezing and caused the beaker to be stuck to the wooden block. In a similar fashion, this simulation is also helpful for exothermic reactions, as modeled in this GIF animation reflecting an alkali metal reacting in water with the vigorous release of hydrogen gas. How can we now cause students to leap from that simulation and real chemical reactions to these so-called potential energy diagrams? The left one reflecting an exothermic reaction, the right one reflecting an endothermic one. I'm showing you here a video of the simulation we've been using in previous lessons, and I'm now trying to give particle A enough speed to break the bond with particle B and the first magnet, and now particle B is making a new bond with the second magnet. In order to make sure that all my students in my classroom are able to grasp this concept, I actually have them complete these diagrams using Pear Deck, as shown here by the Pear Deck interactive icon. It really helps to get every single student to contribute, and it helps me in evaluating every single student in the classroom, even those students that don't particularly raise their hand and contribute to an answer. For lesson 11, students are asked to transfer that speed diagram, shown here, to an empty set of axes, where they're basically connecting the speed of particles A, B, and C, respectively, to the kinetic energy that chemical species would have in a given chemical reaction. The yellow curve represents that trend in kinetic energy. But what about the potential energy? The way that I coax my students to understand that you simply flip the curve is by having them think about being at the top of a hill. At the top of a hill, the potential energy is very high, but the kinetic energy is low. And so when you're at the top of the hill, there's not much speed to be had. And with that particular prompt, students were able to flip that kinetic energy diagram, and here you're seeing in red the corresponding potential energy diagram. The arrows are pointing to the bonds that are formed, and that's where the bicep curl is flexed. The reason being is that for this particular exothermic reaction that we're modeling here, stronger bonds are formed, weaker bonds were broken. Alternatively, when the first magnet is much stronger than the second one, it takes a certain amount of kinetic energy to break that bond, and then a new bond can be formed. This second speed diagram is reflected here, and students were asked the same question. How can we now transfer this speed diagram onto a set of empty axes that reflect the kinetic energy over time? Once the students have transferred the speed to the kinetic energy diagram, they're ready to think about what that would look like for the potential energy diagram. And as before, it is simply a flip of the way that should look like. But the difference here is that much stronger bonds needed to be broken in order for this reaction to occur, and the product bonds are much weaker. So the flexed bicep curl is now shown on the reactant side of this diagram, as opposed to the product side. Next, the lab handout actually asked them to draw these diagrams and label them as such, including the heat of the reactants, the heat of the products, the difference between the two, as well as the activation energy, as so nicely shown in this set of GIF animations. I had my students physically draw this, not in a digital manner, to really drive home this concept. And they are saving what they drew for the next and final lesson 12. And because it's very key that they do this correctly, they were really following me in a direct instruction type of situation. You can already, at the end of this lesson 11, take it to the next step. As shown in this particular GIF animation, if the reaction is not catalyzed in the absence of a catalyst, then the activation energy is much higher than if a catalyst were to be present, which basically lowers that energy of activation in the forward direction. That actually concludes this lesson 11. Key again is to bring those diagrams back into that final lesson 12. Lesson 12, the final lesson of this chemical bonding storyline, is titled as follows: Can we predict whether a chemical reaction will be either exothermic or endothermic? And again, we're bringing it back to reactions that we've done in the classroom, including the one that I described earlier with the beaker frozen to the wooden block. And the second one that I'm illustrating here is the combustion of magnesium ribbon. This chemical bonding storyline very nicely is linked to the following next-gen science standards, including matter and its interactions, and energy change in components of a system. Part 1 of the chemical bonding storyline encompasses 7 lessons total, and all of them are chronicled in the Stunning Storyline playlist. The second part of the chemical bonding storyline encompasses 5 lessons, with the very last one, lesson 12, coming up soon. If you're interested in the lesson handouts and the associated key, go to the link in the description below, and in exchange for your email, you will get a link to the following Google Doc with all my lesson handouts, not just the ones related to this bonding storyline, and their keys, and links to the YouTube videos that might help in you figuring out how to conduct these lessons. Thank you very much for watching. Bedankt voor het kijken. Tot ziens and see you in the next video.